Alright, this matrix here has 2 rows and it has 3 columns. So if we write these 2 rows and 3 columns in this very particular order, this is going to give us the order of the matrix. So again, rows first and columns second. So for example, this matrix here has 3 rows and 3 columns, so it's going to be 3 by 3 for its order. Now within a matrix we have elements. This one has 9, this one has 6, and we have notations to represent where they are. So the first thing you need to look at is the letter of that's representing your matrix. So in this one it's a capital letter B. So everything within it will be a lowercase b, and then it's going to have 2 little numbers next to it. Now each of this number represents things. So the first number is your rows and the second number is your columns. So this one in particular, B13, we're looking for in your matrix B, go to row 1 and column 3. So this number here is row 1, column 3, where they meet. That's the number there. So we can use that to represent the locations of each element. So this number here will be row 1, column 1. This number is row 1, column 2, so on and so. The next thing we're looking at is types of matrices. The column, row, square matrices are pretty self-explanatory. Column matrix is if it has 1 column, it's a single column. Row matrix is single row. And square is if it makes a square. So when you write the order of a square matrix, it's going to be the same number of rows and same number of columns, which will make it a square. Identity matrix is when we draw a diagonal line. So starting from the very first number, you're just going to draw a diagonal that way. That's always the case. We call that the main diagonal. When you do that, if all of the other numbers that's not on this diagonal line are all zeros, then we call that an identity matrix. And a zero matrix is when all the elements in the matrix are zeros. We can transpose a matrix when we have the numbers in the row, make them into the numbers in the column. So we're switching the rows into columns. So here we got 2, -1, 3, and 5. We put that in the second column in that order instead of being in the second row. We call that transposing, and the notation for that is a little t on the top. And then we have a symmetrical matrix, which again, when you draw the main diagonal line, so starting from the first number going down this way, if the numbers on the either side of this line are matching, like this one here, we call that a symmetrical matrix. And then we have a diagonal matrix where only the numbers on the diagonal line are numbers and all the others are zeros. Then we call it a diagonal matrix. And then we have a triangular matrix where we have all the numbers we have in the matrix make a little triangle, because all the other numbers are zero. Then we have these 2 types of triangular matrices. One is lower triangular, where we have the triangles on the bottom, and then upper, where we have the triangle on the top. And then lastly, we have a binary matrix where all of our elements are either zeros and ones. So an example might be, could be in any order. It could be like that, or it could be like that. All right, so now we looked at how to order them, what types there are. Now let's put into some application. So matrices can be used for multiple things, such as when we have a table like this, we can put it into a matrix. So it's going to look very similar. We have our circus, zoo, show here. We got adults and children. And then we put the numbers as we see them. Now the advantage of putting it into a table is that we can do, putting it into a matrix is that we can do calculations on it, where we couldn't do that when it was in the table. And then we can also use matrices to show what kind of connections you have in a graph like this. So here you can see that there are two ways connecting A and B. So we can put it into a matrix like this one here. And we always go from this side to this side. So meaning that if I wanted to go from A to B, so I'm going from A to B, there are two ways. The number I put is here, and it's 2, like that. And we call this a adjacency matrix when we do graphs into a matrix. So let's fill in the rest. So there are no ways to go from A to A. If there was, there will be like a loop like this one, but there isn't one in this case, so it's 0. And then B to A, you can see there are 2 A's, so it's 2 there. And then I'll get you to pause the video and fill in the rest. So pause now. Alright, hopefully this is what you've got, matching the numbers that I have here. And the last example we'll do together today is this one. So this is from one of the past exams, and this one looks really complicated. So have a read first, and then we'll do it together. Alright, the reason why it's so complicated is a bunch of numbers, a bunch of letters, and letters are usually confusing. There's so many letters here. But the key information here is row is I and column is J. So an element in this matrix P will be represented as Pij. So for example, if I take this number here, I can represent that as P11. This one will be P12, and so on. And in this case, I is 1, J is 1. In this case, I is 1, J is 2. That's all it is. But then there are all these rules, and it's asking you the elements in the matrix are determined by which rule. And these rules are very hard looking, but to do these types of questions, all you need to do is pick a number. I'm just going to pick this 5 here. And then you want to put it into the rules and then see which one works out. So it's a bit of trial and error. So let's do A here. So it's saying Pij is 4 minus J. So if I pick this 5 is P row 2 column 1. So that means for this one, I is 2, J is 1. That's for this 5 that I picked. And I just picked it randomly. You could have picked 4, 3, any other numbers here. And then what you want to do is put it into this rule. So P21, is 4 minus j, and in this case our j is 1, which equals 3. Now this rule is invalid because we obviously want this to equal to 5. So A is not the answer. And then I'm just gonna, actually, I'll do B as well. I'll try not to be too lazy. Yeah, I'll just write down the rule, which is 2i plus 1. Again, we're still dealing with this information here. That's our number, 5. Too much pink. This information here. So let's see, P21 is 2, and in our case, I is 2, plus 1, and that is 5, which is great. So this may be our answer, but just to make sure, you should pick a different number. Let's pick this number here, 2, and try it out with that one as well, see if it works out. So I will try that. So P 1 2, so our 2 here is P12. We did it over here, P12. So I is 1, J is 2. So it's 2 times I plus 1, which is 3. So this one doesn't work out. It needs to equal to 2. So actually only worked for this one but not for this one. So it can't be the rule. The rule should work for all of the numbers. So B is not it. And then you continue on with C, D, and E. And I know, because I've done this prior, E is the answer. Let's see how it works out with E. So Pij equals 2i minus j plus 2. So let's see if it works out with our first number that we picked, which is 5. So it's 2 times our I is 2, our j is 1 plus 2. So that's 4 minus 1 plus 2, which is 5. So that one works out. Now let's try with 2. So that's going to be 2 times I. I'm just going to go over here. Minus j plus 2. That is also 2. So this one works out. So the answer for this one is E.